So same scenario, but now we have a bank that's compounding monthly, and we want to see how much we will have in 5.5 years. Let's think about that number of years thing again. If we're talking about monthly, how many years, how many months in half of a year, because we have half of a year. So half of a year is 6 months, and that's a whole number of months. We're not at 5.5 months or 7.5 months. We're at exactly 6. So I think we'll be able to get interest for every single month. And so let's think about how many times we're going to have to do this calculation for 5.5 years, and we have to calculate the interest every month. So we're going to have 5.5 times 12 months per year. That will be 66 times that we have to do this calculation like we did for the annual. I, for one, have no interest in doing that, so I would like to show you a quicker way. If we work out a formula for this, because you notice that we're doing the same thing every time, this 1.025, and we can think of it as times itself, 1, 2, 3, 4, 5 times, so to the 5th power. So we can use that. Mathematicians came up with a formula that came from the simple interest formula, but it looks like this. A equals PV for present value or starting value times the quantity, 1 plus, remember that 1 plus we had up here. This time we take the rate and divide it by the number of times we compound in a year, times that number of times we compound in a year, times the time. And if we're compounding monthly, then monthly means there's, how many months are in a year? 12. So we do n equals 12. For the n is how many times in a year you'll do your compounding. So if it's monthly, there are 12 times in a year that you'll do your compounding. If it's annually, which is what we had up above, then it'll be 1 time in a year that we do our compounding. So that's what that N stands for. And then the R and the T are just what we had before, and the PV, that's our starting value, and the A is the ending amount. So let's try it out. So we have $5,000 that we're starting with. 1 is just a 1 plus, and our rate is going to be 2.5%, so we can do 2.5%, or we can write it as 0.025, either way, over our N we decided was 12, and the N again, 12, and then the time. So T is time in years, and so it's 5.5. This exponent needs to come out to a whole number. And the other thing about it is it's an exponent or a power. You can't just multiply by it. It has to be a to the power, and we'll use. So when I look at my problem, I know I need to work inside the parentheses first, but I'm going to tell you, go ahead and calculate this exponent. Remember, it is an exponent. It's not multiplied by, but it's raised to the power. So this button here, to the power, we'll be needing to use. So I want to calculate it, 5.5 times 12, and I get 66. That's good, it's a whole number. So instead of this, I can say 66 compoundings exactly. And then what I'm going to do is calculate inside of here, and then I just know I need a to the 66 when I get to this point. Think of this button, I always call it your to the button, but think of it as an exponent button. So I have 3, for example, 3 to the 2nd power, that's 3 squared. So 3 times 3 should be 9. So when I push equals, it's 9. So that's how we do that button. And on this problem, we're going to be taking our quantity in parentheses to the 66th power. So here I'll start on this fraction, and I'm going to show you as 2.5% divided by 12 equals, and then I'm just going to add in that 1 that we had, and then I'll write it down over here. So far, here's what I have. 5,000 times 1.0028083, and it looks like those threes repeat to the 66th. At this point, you need to ask, what's the order of operations? Do I handle exponents next, or do I handle multiply next? It's really tempting to go ahead and multiply by 5,000, but it's not correct. We do need to do the exponents next. So this 1.028083 repeating to the 66th, that's the operation that has to happen next. That number 1.0020833 repeating is sitting there on my calculator. That's beautiful. We want to leave it there and just take it to the 66th power. So I'll use my to the button. To the 66th power equals, and now I've handled the exponent, so that's going to give me, I'm going to just rewrite over here. Now my problem is 5,000 times 1.14723, and it goes on and on, so I'm just going to put that dot, dot, dot. But now I'm down to one operation left, and that's the multiply in between the 5,000 and the number in parentheses, so I will do that next. Times 5,000 equals, and now I have 5736.18, but I have an 8 following right there, so I need to bump up this 8 to be a 9. And remember, this is money. And so this person, you, will have $5,736.19. And that's quite a bit more than what we are going to have compounding annually, because remember, we couldn't get that extra half year on this compounding, but here we did. We got every single month that we could.